Let's discuss each of the main elements of a safety plan in turn. We'll start with safety standards. Safety standards typically deal with functional safety. Historically, the idea was that there would be a separate safety mechanism that, for example, performed a system shutdown in the event of an unsafe situation. That shutdown system would be the safety function. So the starting point for functional safety is that there are separate safety functions that can be activated to bring the system to a safe state. The prototypical current safety standard is IEC 61508. This standard was specifically designed and intended to be a basis for other domain-specific safety standards. It is also the primary functional safety standard used in the chemical process industry. Other domains have specific standards tailored to their needs, such as ISO 26262 for automotive applications, EN 5012689 for rail applications, MIL Standard 882 for combat systems, IEC 6730 for consumer products, DO 178 for aircraft, and so on. Each of these standards is a bit different in how it approaches safety, but at a high level, all of them have some key characteristics. This figure shows the steps required by IEC 61508. Safety analysis starts with determining the hazards and risks for the system. Usually, a safety integrity level, or SIL, SIL, is assigned based on the severity of the risk. Higher severity mishaps are assigned a higher SIL. For example, in 61508, a mishap that might result in multiple fatalities or the destruction of a chemical processing plant would be rated SIL 4, whereas a mishap that is quite minor might only be SIL 1. The SIL, in turn, determines the level of engineering rigor required for analyzing and designing the system. A SIL 4 risk requires a tremendous amount of engineering effort and redundant hardware to mitigate the potential for those very severe mishaps. On the other hand, a SIL 1 level of risk requires more or less good engineering care, with some specific techniques being required to ensure that level of care is actually present. SILs 2 and 3 require in-between levels of care, with a higher SIL number requiring more engineering care, more engineering rigor, and the application of more specified techniques. Any good system safety standard takes a life cycle view of safety. That means that it not only covers system design, but also system validation, maintenance, and feedback from observed in-service incidents to effect continuous improvement of safety. It also includes any safety issues relevant to decommissioning and disposal.